Hello, everyone. We're going to talk about predicting US airfare through market structure by our website called FareCheck. I'm Karina.
I'm Edwin.
I'm Audrey.
So the problem that we're trying to solve is that travelers often experience airfare as unpredictable. So our solution builds a predictive model and a user web interface that estimates a baseline expected airfare using core structural factors to explain the market fundamentals. Uh, we also quantify each feature's contribution and clear up various misconceptions about why prices change.
Okay, so for our data approach, we basically started by doing feature categorization. So we categorize features into four main categories: distance, demand, competition, and endpoint hubs. And then we use visualizations like scatter plot to examine the linear relationship and then the strength of relationship for each of the factors with fare. And then after we got the relationship, we put them into a real world economic context to study further about the relationship, including any potential confounding variables, and then also the economic intuition behind the relationship.
We modeled the fare prices using XGBoost, which is designed for high performance and efficiency, which makes it great for our supervised regression task. We removed the variables fare large and fare low, since those variables are very closely tied to the fare itself. And as a baseline, we also trained a random forest model, but we found XGBoost to be more performant. Our final model suggests that the model is properly fitted and that overall prediction errors remain small based on the R-squared score, MAE, and RMSE.
Okay, so from our result, we have a chart of the feature importance calculated by SHAP values. And then we can see that NS miles, which stands for distance, rank as the most important feature. And then this is followed by the total premium or discount, and then which stands for the characteristics of the end hubs. And then it's also followed by passenger, which stands for the demand category. And then lastly, we have the market share for the airline with the lowest fare, and then the largest market share of the largest company in that airline, which stands for the competition category. And then from our results, we would like to break some common myths that are on airflight tickets. So there's a myth that large airports are always more expensive, which is not true because large hub airports such as San Francisco and New York often have low fares due to the greater competition. And then this can also be shown in the chart below. So we calculated the mean fare for the company with the largest market share, and then we also calculated the mean of the largest market share in the larger airports, and it can be seen that the mean for the larger airports is lower. Another myth is that long-term air flights are cost more per miles, which is also false because short routes usually have a higher price per mile as fixed costs can spread over fewer miles, which can also be seen in the chart on the right. So as the average fixed cost decreases due to output increases, the average total cost also decreases. And then this shows that distance do increase with airfare, but is with a decreasing rate. And then from our website, we provide a data-driven tool for travelers to make more informed decisions on their budget constraints. And then we also reduces information asymmetry by providing the context of how the price changes.
Next page. So before I show you the a demo, I will just explain about the SHAP. So our XGBoost is highly aggregated, but it's not essentially a black box. So we can know the predict well, but we don't know the reason why. So the SHAP just solved the problem. So it comes from a game theory. Imagine each feature, each variable as a player in the team, and a predicted fare as the final score. So the SHAP asks how much did each player actually contributed to the final score, and the result is that for every single route, we get a dollar value for each feature. So the distance added $33, a monopoly added $47, low cost carrier represents saved $18. So it turns out a black spot into a fully explainable system. Next page. So let me show you the tool we built. It's a web code fare check. So the idea is simple. So it's like most travelers don't have an idea about why a ticket is so expensive. So is it because the route is so long, or it because one airline dominated the market, and so the fare check can answer a question. So first you can select the origin and the destination from the US cities, and the tool calls our Flex backend, which runs the real attribute model in the real time and returns three numbers. Next page. It returns three numbers: the predicted fare, the distance baseline, and also a structural premium on top. So it will give a verdict about the green means the competitive prices, yellow means a moderated premium, and red means the high structural premium driven by the monopoly or the hub effect. So it also shows about the breakdown of which features are driving the prices based on our SHAP weight. So in the examples, the premium is about $68 and the verdict is red. So the traveler can look at a ticket, just sees a prices, but our tool can show them it's not about the distance, so it's about the market structure.
And that concludes our presentation. Thank you.